Hi everyone, welcome back to my channel Siva Academy Technical. Today we are going to discuss the remaining properties of Laplace transform. In the previous class we have discussed the first two properties, that is linearity and time scaling property. The next property is time shifting property. The third one is time shifting property. Okay, so we know that f of t is a function in time domain which is having Laplace transform f of s. So I can write here statement that is f of s. F of t is a function in time domain which is having Laplace transform f of s. So I can perform the shifting in two ways. First one is right shifting and second one is left shifting. So I can write this f of t minus t naught, which will give the Laplace transform f of s multiplied with the e power minus s t naught. And also I can write f of t plus t naught, which will give the Laplace transform f of s e power plus st naught. This is a statement of the time shifting. Here we can observe, so f of t minus t naught. So this is called right shifting, this is called left shifting here. So we can shift the function f of t to the right side by the factor of t naught. So we can shift the f of t to the left side by the factor of t naught. Okay, here the t naught is a factor by which we can perform the right shift. Okay, and also the minus sign is same as that we are having in the time domain function, the minus and minus. So minus in time domain, minus in exponential function. And also t naught is a factor by which we can perform the left shifting. And also plus sign is same that we are having in the time domain. Okay, that means here the time shifting in the time domain is a exponential multiplied in the s domain. So and also having the same sign in the exponential and in the time domain. Please remember this point here. So plus in the time domain and plus in the exponential function. Okay, so to understand this time shifting, so I can take a simple example, that is find Laplace transform of u of t minus 2. It is a time shifting version of u of t function. We know that Laplace transform of u of t is equal to 1 by s, that we have calculated in the previous class. Laplace transform of u of t is equal to 1 by s. Now we can apply the time shifting property. U of t minus 2 is equal to this is a right shifting here. Can you find out the which type of shifting here? Right shifting. So minus 2 is a minus 2. So it is a right shifting. U of t minus 2. So we can apply the formula f of s e power minus t naught. So f of s is the Laplace transform of u of t, because it is a time shifting version of u of t function. So f of t is equal to u of t, then Laplace transform of, that is u of t is equal to 1 by s. Then 1 by s in the place of f of s, that is 1 by s, then exponential multiplied e power minus s into, so we can shift the u of t by the factor of 2. Therefore in the place of t naught you can substitute 2. So minus s into 2. So I can write 1 by s into e power minus 2s. This is a Laplace transform of u of t minus 2 by using the time shifting property. Okay, next property is here frequency shifting. The fourth property is frequency shifting. frequency shifting. Okay, same thing here. So you know f of t in time domain, which is having Laplace transform f of s. Here the name indicates the frequency is shifting. So there is a shifting in frequency. In this case here, so shifting in time domain. In this case, shifting in frequency domain. So we can shift the frequency domain to the left shift and right shift, but we will have the exponential function in the time domain. That is, you can write like that here. So f of s minus s naught. So we can shift the s domain to the right side, and we can shift the s domain to the left side. Okay, f of s minus s naught, that is e power s naught into t f of t, and this is the right shifting, and left shifting is here f of s plus s naught and e power minus s naught into t f of t. This is a frequency shifting. Okay, see here, please observe here. So this is s naught, t minus t, s minus s naught, here t minus t naught in this time shifting, time domain. In this case here, s minus s naught in the frequency domain. So we can shift the s domain by the factor of s naught. In this case here, we can shift the time by the factor of t naught. Okay, in both case here, both case we have exponential. So in this case we can multiply the exponential in the s domain, but in this case we can multiply the exponential in the time domain. That is the only difference. One more difference is there here. Here whatever the sign is there, plus sign is there here. The sign is not same that we are having in the s domain, and also this is the minus sign which is not same that we are having in the s domain. It's minus and plus. So s naught, what is the in s domain? We can write is s minus s naught. We can shift to s minus s to s naught by the factor of s naught. So s naught, s plus s naught. You can write like that. So this is s to s naught, s minus s naught. Okay, please remember this frequency shifting formula is very important to calculate the any Laplace transforms. Okay, so just take an example here. Find Laplace transform of f of t is equal to e power minus at cos omega t. See here, there is a exponential function which is multiplied with the time domain function. Okay, so this is a, now can find out the Laplace transform by using frequency shifting. Okay, na? Here in this case here, so which type of shifting here? It is a, whether it is a right shifting or left shifting. Definitely it is a right shifting. So here, sorry, this is a left shifting. It is a left shifting. So by the factor of a. So cos, what is f of t here? In this case, f of t is equal to, if we compare this here, f of t is equal to cos omega t. If we compare this and this formula, then cos omega t is equal to f of t. What is the Laplace transform of f of t is equal to, we know that we have calculated in the previous class, that is s by s square plus omega square. Now find out the Laplace transform of f of t is equal to, that is, first is, we can shift the function, by the factor of a, that is f of s minus s naught. That is, we can replace the s with s plus a, Sure, s naught is here, s naught is a here. So we can replace the s with the s plus a, that is this function. So s plus a by and s plus whole square and omega square. So according to the formula here, it is a left shifting here. this e power minus ct cos omega t. If it is minus is there, definitely there is a plus in the frequency domain, that is left shifting by the factor of a here. So first of all, you should try the Laplace transform of cos omega t. We know that is s by s square plus omega square. Okay, now we can shift the frequency domain by the factor of a. So s plus s naught. In the place of s naught, there is a is there. So s plus a. I can replace with s is with the s plus a and s plus a whole square omega square. So this is the Laplace transform of f of t. That is e power minus a t and cos omega t. So s plus a by s plus a whole square and omega square. So these are the two properties here. So time shifting property and frequency shifting property. So please remember these two properties. So these are very useful while calculating the problems to find out the Laplace transform of time domain functions. Next property is here time differentiation. Next property is fifth property here, time differentiation. Time differentiation. Time differentiation. Okay, here you know that same thing here. So f of t is a function in time domain. F of t is a function in time domain which is having Laplace transform f of s. So that if the function have differential equation, if you apply this, if the function have differential equation, that is d by dt of f of t. F of t. This is a differentiation. That is d by dt of f of t. If you take differentiation of f of t, so which will give the Laplace transform according to the time differentiation property. So that is we can multiply s with f of s. S into f of s minus f of 0 minus. The time differentiation derivative in the time domain which gives the that is s into f of s minus f of 0 minus s. Just we can multiply the s with Laplace transform of f of t and we can subtract this value with initial value. So f of 0 minus indicate the initial value of the f of t function. Okay, na? Initial value of f of t function. So if you take one more derivative d square by dt, second order derivative of f of t, and same thing here can apply s into this function, s into f of s minus f of 0 minus and initial condition of this function. So minus f dash of 0 minus. Okay, this is general formula. So d by dt of f of t. So the property of time differentiation is here. So the time derivative of f of t function which gives the s into f of s minus f of 0 minus s. So we can subtract the initial. So we can subtract this value from this value. So s of s into f of s. Just we can multiply s with function f of s. Okay, and we can subtract the initial value from this. So because f of 0 minus is the initial value because of, so the circuit which is having some capacitors, inductors which are storing elements, because of energy storing elements which has some initial current, initial voltage values. Okay, that's why I can represent so f of 0 minus s. If it is 0, you can substitute 0 values. Okay, definitely which has some initial values. Okay, so according to the time differentiation property, so d by dt of f of t, that is which gives the Laplace transform s into f of s minus f of 0 minus. Then again if you take the one more derivative, second order derivative of f of t, that is same s into f of s into this What is f of x? This total is function. So s into f of s minus f of 0 minus s is function, and initial value of this derivative d by dt of f of t minus f dash of 0 minus. This is called as a time differentiation property. So please remember, this is very very important to calculate, to get the solution of time domain function. Okay, yes. So now I can take an example for this one. So find Laplace transform of d square y by dt square plus 12 into dy by dt plus 32 sorry, this is okay, 32 is equal to 2 into v of t. This is my differential equation. This is a function in time domain. So find Laplace transform of this function in time domain, and provided initial conditions are 0. Provided initial conditions are 0. Okay, so just we can write here. So d square solution. So d square by dt square plus 12 into dy by dt plus 32 y of t, sorry, this y of t and is equal to 2 into v of t. Okay, now apply the time differentiation property. This is the second order derivative. You know that here, yes. So just here simplify here, multiply here because of by the homogeneity property. S into s, s square f of s minus s into f of 0 minus f dash 0 minus. Okay, same thing here. This is the second order derivative of function y of t here, y of t, right? So s square f of s here. What is the f of s here? The function is f of s. The function is y of t. So y of s and minus s into initial conditions of function f of 0 minus and minus f of 0 minus. Okay, next plus 12. So dy dt is first order derivative. So s into f of s into this y of s minus initial condition. Sorry, this is a function of y of 0 minus y of y dash of 0 minus. This is a y of 0 minus plus 32 y of t, Laplace transform y of t is y of s is equal to, you know, Laplace transform of u of t, input signal is 1 by s, that is a step signal is 1 by s. Simplify here, you know that here. So all initial conditions are 0. So y of 0 minus, y dash 0 minus and y of 0 minus, all are zeros. Then s square y of s minus, sorry, plus 12, just to multiply, account the homogeneity, 12 into s, 12s y of s minus, sorry, this is 0 here, this is 0 and this is 0, plus 32 and y of s is equal to 24 by s. Okay, next. So all terms, in all terms here, what is the common here? Y of s is the common. So y of s is the common here. So s square, remaining s square, and 12 plus 12 into s, sorry, into s. So s into 12 plus 32 is equal to 24 yes. 24 yes. So I can have y of s. So you can bring this side here. So y of s is equal to 24 by s into s square plus 12s plus 32. This is a Laplace transform of, that is y of t, by using time differentiation property. Okay, like this. So we will calculate the any problem. If any function in the differentiation, then you can apply the time differentiation property. Okay, and in the next class we will discuss the final property, convolution property. Okay, and thank you very much. So my dear aspirants, so please subscribe my channel if you are satisfied. If you are satisfied with my channel, please subscribe, because of if you encourage me, so that will help me to make more videos. Okay, na? Please subscribe and please give encouragement to me. Okay, and thank you very much.